Okay guys, we need to go further ahead with our diagnostic troubleshooting by powering up this control card. Only we are actually interested in three wires. One is a 12 volt battery, replacing the battery power, ground, and a VSS a 5 volt pulse to make sure that this card, as well as the motor we earlier suspect that is not working, whether it's not working with using this card. For that reason, I have it's very simple circuit, which we need a pulse generator, and we use a good old 555 timer. But one thing, since we're gonna be using 12 volt to power up this control card, you need to step down the 12 volt to 5 volt, and for that I used voltage regulator 7805, and I'm showing this rough diagram. With 9 volt battery, you can put between 5 volt to 18 volt input to this, and there's a capacitor, coupling capacitors on both ends, which gives us a fixed 5 volt out, and this 5 volt we feed into the stable timer circuit 55. This is 555, and these are trim pods, 1 mag, and the output is pull up resistor, which gives a 5 volt pulse. The frequency can be changed by R2, and there's a lot of you can do. It's a very common timer. You can find a lot of information over the internet. This is how you determine what frequency the pulse gonna be. But since I have put a variable potentiometer trim pod, we'll be able to do that. Here you go. There's a duty cycle, 50 cycle. Though I'm not gonna go too much detail, but I'm gonna demonstrate this circuit right here, which is showing the same thing. Is there's a 7805 with a good heatsink, and then a 555 timer with all the capacitors in place, and there's a pull-up resistor right there. What is these wires are? There is to the voltage regulator 705. There is a lines coming. There is 12 volt in here, fed into the input of the voltage regulator. We are getting 5 volt out, and that 5 volt is this is a 5 volt fed into the 555 timer, which is running on astable mode, and then the output from the pull-up resistor is just to further display this LED. We're gonna power it up with 12 volt power supply, and we'll see what we get. Okay, so here you go. The LED, we are getting a pulse, 5 volt. Not 5 volt at this time, because LED is there's a drop in the voltage, but we're not gonna use this LED when we gonna use this circuit for our VSS 5 volt pulse signal. But here you go, we can R2 can be manipulated to change the frequency. Oops. As you see, the frequency is increasing. Okay, so we can give a different frequency pulse to our feed into our green connector, which is going to be used by the stepper motor driver, the Toshiba chip. Somehow, okay. So this is pretty cool. We're able to do that. We can check it with our probe 2. Let's see what we are getting. Just showing there's a pulse. So this is it. This is our simulation for VSS signal, and we'll plug in this signal to our control card here. I already determined what pin is for 12 volt power supply plus ground and plus VSS. So next thing we'll try that and see whether our original motor, which is this guy here, is turning or not. And we don't expect it to turn, because that's the whole reason we are troubleshooting the whole odometer circuit and mechanism. But we'll have some signal to test whether the motor is getting its magnetizing pulses to make it turn. Okay, we're gonna go ahead and plug in. You see, there's a control board plus our breadboard, which has a pulse. Green wire is a pulse which is coming from the breadboard. I'm going to take the LED out later because that's going to cause a voltage drop. We want 5 volt pulse square wave, and here is our astable circuitry here, which is kind of out of the sight, but we're gonna first connect, take out from the pin, connect these custom made lids, which is easy to make with the 3 wires. One is a 12 volt pin, if you see, able to see one, these gonna connect to this pin of this green connector. One is ground, one is 12 volt, and one is green wire, which is gonna connect to the pin 8, which that's how we're gonna feed the VSS, simulated VSS signal into the board from our breadboard. Okay, here you go. We have plugged in our 12 volt lid into the connector. That's a pin 10 and pin 9 and the green one is pin 8. Okay, and we'll feed 12 volt from the power supply 12 volt power supply. It's coming here. See, and the ground is here. Ground, and this green green wire gonna come to this pulse pin from the breadboard, which gonna feed the 5 volt pulse into the pin 8 of the control board. I'm gonna go ahead take out this LED. We don't need it. And next thing, I'm gonna connect our motor, stepper motor, which came out of this odometer, into the connector here, using the lids, not directly connecting. Though we can, there's a perfect connector here, we can plug in there, but we're gonna avoid right now because we are on test mode. We need to make sure that all these connections are working fine, and should be. But for the test experiment, we'll connect the lids to this motor connector, and then power the circuit up and see whether this motor is rotating or not. And we don't expect it to rotate, but we be able to test the signals going back and forth to confirm the board is functioning correctly. Okay guys, I have connected all the wires accordingly to our odometer motor, the original one, and so there's 6 wires coming out of this connector here of the motor, as you see. Okay, and I put something there to be able to see it moving. Out of the view. And connector for the stepper motor on the board, all 6 wires going in accordingly. I have already determined the phases from that, as I showed previously. The stepper motor driver give us a hint, and these are the phase pins. Pin 13, 14, 15, 16. Okay, and also, as I mentioned earlier, I had